Hi, in this video on my Arduino Mega2560 I want to focus on two things. These are the NTC again. It's being heated by a lens lamp, but the values in the serial monitor are not convincing me. That is how they work. And second, I want to add another element to this little circuit of a capacitor and the LED, and that element is this inductor. So that is what I primarily want to do today with this Arduino, and to see how this inductor fits and responds to the circuit, I will once again use the XCOS simulator of Scilab. So let's see how things go. So let's first check out the NTC. They should, of course, NTC, but that doesn't matter too much. I will upload it once again. Let's first check the whole code for the NTC. Now it is analog in pin is A7. Sensor value is the read from the NTC, and looking here, it reads the NTC. So here it actually reads it, and here it prints it. So let's upload. So it compiles the sketch, upload it, done. So let's first look at it without the fan running, and what we can see is that the value is primarily 10. An NTC has the property that with increased temperature the resistance or the resistor value decreases. So assuming that this is in ohms, it has now around some 10 ohms. So basically, when I turn on the fan by turning on the pot meter, the value should increase. So let's see how that actually does work out. And the only problem is also with this fan that the motor driving the fan starts with a certain speed, and that's a downside. So it doesn't start slowly, unfortunately. Anyway, let's see how this works out. Very slowly, very slowly, very slowly. And much changing values with the NTC. Around, well, 4 in the 30s, and then back to say 7. So let's increase it even more. primarily in its stand now. Very low speed, very low speed, with changing temperatures, well, changing readings anyway, really running slow now, very slow, and primarily low values. So, and now the fan is off, and the afterburst. So it may be that it works anyway, but what I don't get is that the values are quite changing with the fan running. So I think I will have to look into that a little bit more. What I can also do is try to find another motor. The question is if that is really going to change matters, but I think that would be a good idea. The motor I use right now is from Technique, just a simple motor. I also have a power motor, and yeah, I think it may be a good idea to change that. So let's first get to changing the motor. Unfortunately, the power motor didn't match the fan, so I couldn't mount the fan on it. Found another motor which is a lot smaller, so that's no match for this motor. However, I decided to change the setup of the motor, so now I have reversed the direction of the fan, so it actually in this way blows directly to the NTC, with the lens lamp pointed directly very close to the NTC. And let me show how that works. So now it blows straight to the NTC. And let's see how the serial monitor shows. So when now looking at the NTC, the values are quite low, although with some odd values into the 20s. So when I change the direction, change the speed of the fan, those values disappear. Well, a value in 10, but most values are very low, which indicate that it should be a high temperature, but that can't be, because the NTC gives low resistance with a high temperature. So let me put down. Okay, the fan is now switched off. Very low temperature. So, and the lamp very close to the NTC again. So the values are a mystery to me. Now the fan is at the strongest. Low temperature should be high resistance, and I can't verify that, not with the values I'm looking at. So I really should find out in which way the outputs of the NTC should be working and should be regarded. Which leads me for this time to the next focus, which is the addition of inductor to the part of the circuit where the capacitor is. So let's go there. And with that I change here for the Xcode simulation. The inductor has a value of 100 microhenry, and the question is, where should I put it? I think I should put it here. So no, I can't do that. That's one thing. Shifting this, and let's put the inductor here, electrical, and this is an inductor. And for the real test of the inductor, I've put the inductor as in the simulation, so resistor, inductor, capacitor and the LED. And as you can see, I removed the motor for this moment. And let's see how the LED actually does behave. And it doesn't behave at all at the moment. So let's see why that happens. Probably because the wires of the potmeter are out. At least one of them. That should fix it. There's only one wire to fix. That is okay, so let's try again. And for some reason it doesn't work, because I don't see the LED burn at all. While I can obviously see the other LEDs run or burn anyway. These work and this doesn't burn at all. So the question is, why doesn't it do it? So let me remove the inductor for now. Put the resistor back in its original setting. So now this circuit is in place again. And try again. And as far as I can see, there's nothing happening with the LED yet. So that's quite odd. I'll have to check on the circuit. After checking the wires, it turned out that one of the wires of the capacitor was not completely fixed into the breadboard, so now it should all work. And of course experiments can go wrong at any time. So before taping this or recording this it works, and now for some reason it doesn't. Let me short circuit it and try again. And now you can see it does work. Totally on the right on the screen. The red LED slowly dims. And let me short circuit it again and do again. Red LED completely brights up and slowly, very slowly dims. Actually it dims slower than without the inductor, so that's also interesting to see. And now it doesn't work anyway, so I'll short circuit the capacitor again. And one final try. And there it goes again. Full brightness. And a very, very slow dim. So this shows that the circuit is working. And with this I like to end this experiment. So the two focuses of this episode were the motor, where I have some serious questions on the value on the NTC. I think its behavior is a bit odd, but that may also mean that I interpret the values and the behavior of the NTC wrong. On the other hand, the circuit with the addition of the inductor works quite nicely. So thank you for watching, and to be continued with some more nice experiments.